Hello everyone, my name is Benson Abraham, Assistant Professor, Department of Botany, Kamla Nehru Mahavidyalaya, Nagpur. Today we will discuss on a topic Introduction to Electrophoresis, which is a part of BSc Sem 6 syllabus of Botany, RTMNU. To start our class, let us discuss the definition of electrophoresis. Electrophoresis is the motion of dispersed particles relative to a fluid under the influence of spatially uniform electric field. That is, when you apply electric field in a medium such as liquid, you apply it by two electrodes. The positive electrode is known as anode and the negative electrode is known as cathode. When this electric field is applied over these electrodes, the negatively charged anions migrate towards anode and positively charged cations migrate towards cathode. This phenomenon is known as electrophoresis. Hence, we can say that the phenomenon of electrophoresis can be of two types: cataphoresis and anaphoresis. Electrophoresis of positively charged particles, that is cations, is cataphoresis, and electrophoresis of negatively charged particles, that is anions, is known as anaphoresis. The process of electrophoresis have many applications. Especially, it is used to separate macromolecules based on size. It is also used in analysis of DNA and RNA. DNA footprinting, a technique which is used to know how a protein binds to a particular DNA sequence. Plasmid analysis and separation and purification of proteins. The components of electrophoresis includes the following: a buffer system, electric field, a medium or gel, and voltage and time given for electrophoresis. When you perform electrophoresis in a medium, there is a chance that the pH of the medium changes, or the pH of the maybe the macromolecule may also change. This may interfere with the kind of results we appreciate. To prevent that, we use buffer systems. Buffer systems resist the change in pH. The various buffer systems used in electrophoresis depends on nature of sample and the experimental objective. Mostly, the buffer used may be same for both cathode and anode, but depending upon the experimental procedures, they may be different also for each electrodes. After buffer system, the next component is electric field. Now, we know that proteins and DNA are mostly negatively charged, and so they migrate from cathode to anode. And this has been taken care when you make an instrument for electrophoresis. The next important component of electrophoresis is the medium in which electrophoresis is taking place. It can either be a solution or a gel. For most experimental procedures, we use either a polyacrylamide gel or agarose gel. The migration of macromolecules in gel depends on its size. Small molecules find it less difficult to move from the pores within these gels, whereas the large molecules move with difficulty. Hence, we can say that the differences in the rate of migration of different molecules depending on their size acts as a mechanism for separation of molecules based on their size. The next important component is the voltage and time given for electrophoresis. At higher voltage, the separation may be quick, but you may have to compromise with the accuracy, and therefore you have to standardize the time and the voltage which is applied for an electrophoretic procedure. Generally, it takes few hours to complete electrophoresis. Let us now try to understand the principle of electrophoresis and migration of ion during electrophoresis. Now, for our understanding of the principle of electrophoresis, let us consider a spherical molecule which is having a charge Q and is placed in an electric field. Now, because of this electric field and the charge present on the molecule, a certain force will develop on this molecule. This force exerted on the molecule depends upon the density of the net charge on the molecule and the strength of the electric field applied. Hence, we derive that force acting on the molecule is equal to the potential difference applied between the electrodes and charge on the molecule, whereas d is known as the distance between the two electrodes. Let us number this equation to be 1. Now, any molecule to move in a medium, it has to overcome the frictional force that is exerted on the molecule because of this medium. This frictional force exerted on the molecule can be calculated as per Stokes' equation, which says that frictional force is equals to 6 pi Rnv, where R is the radius of the molecule, N is viscosity, and V is the velocity of migration. Let us number this equation to be 2. So, in order for a molecule to move in a medium, it has to overcome a frictional force. And this will happen only when the force acting on the molecule due to electric field and charge present on the molecule equals the frictional force. Thus, we now equate equation 1 and equation 2 and get the equation 3, which talks about the velocity with which a charged molecule migrates within the medium on the influence of electric field. And by looking at this equation 3, we can conclude that velocity of the molecule during electrophoresis is directly proportional to the potential difference and net charge on molecule, and inversely proportional to the particle size and viscosity of medium or gel. This is the principle of electrophoresis. So in today's class, we learned about the definition of electrophoresis. Then we also looked about its application, various components, and finally we discussed about the principle of electrophoresis, which states that velocity of the molecule during electrophoresis depends on various factors such as net charge on the molecule, its size, viscosity of the medium or gel, and the electric field applied. Thank you. Have a great day.